Welcome to Microsoft Excel with EJD. In this video, I'll be talking about random number generation with analysis ToolPak. Of course, analysis ToolPak is that add-in in Excel that helps us to do statistical analysis by just clicking a few buttons. Okay, so the random number generation tool in Excel's analysis toolpak is a powerful feature that allows users to create sets of random numbers following specified statistical distributions. All right, it is especially useful for simulations, data modeling, experimental design, and bootstrapping methods in statistics. So if you ever get to do anything that involves the use of random number generation, the use of random numbers, right? So you can actually generate such random numbers using the random number generation tool in analysis toolpak. So let's go straight and open a new Excel file. So I just go now. Okay, I'll just search for Excel. Okay, have this. So I have this new Excel thing here right now. So I open a new book. Okay, let's go home. Now, we want to generate random numbers. And since you're talking about the analysis toolpak, you want to be sure that you have it there. And where to check is click on data. All right, click on data and be sure this data analysis is there. If it's not there, what do you do? So what I'm going to do is I'm going to remove it and put it back so you can understand the process. So I just go to file. So after going to file, I come to options. The same way we got solver, for linear programming under what if analysis. Then click on add-ins. So from there, you click on go. So here you see analysis toolpak, just like we saw solver before. So click on analysis toolpak, uncheck now, and click OK. So you see there's data analysis here right now. When you uncheck, data analysis is gone. And with it gone, you cannot generate random numbers like that. So how do you get it back? Come again, file, options, add-ins, go, then check the analysis toolpak and click on OK. Then you see data analysis comes back. So with this now, we are ready for random number generation. Okay. Of course, as the name implies, random numbers are just they are numbers you don't pre-think about them. You can just have them come up. So I click on data analysis now, and then I look for, there are many tools. We've been taking the tools one after the other. So I'm interested in random numbers. So I click on random number generation, then I click on OK. So the question is, how many variables do I want? Maybe if you want 3 columns, for instance, you can say 3 variables. So let me say 3 variables this time. So I want variables 1, 2, 3. So, I mean, whatever. And then number of random numbers. So that's talking about the number of rows. Now, number of variables is number of rows, and number of random numbers is number of columns. Let's say I want 50. I want 50 random numbers generated for each variable. Then which kind of distribution do I want? Do I want discrete, uniform, normal, Bernoulli, binomial, Poisson, patterned or discrete or patterned? What exactly do I want? So, well, let's go one after the other and see. So I'll open cell by cell and use each kind of distribution. So I go uniform in this case, and then we want the uniform. If you want uniform distribution between 0 and 1, if you want that, or you can specify what you want basically. Okay, and don't forget it's random number, right? So you're going to have the uniform distribution between 0 and 1 for each of the 3 columns. So let's restrict it to random, 0 and 1. Then for random seed now, random seed, just like what we have in Python, the random seed is to ensure that users can specify a seed value for reproducibility, ensuring the same set of random number is generated in future sessions. So if you don't want, since it's random number, right, but you still want exactly the same to come each time, so you can put the random seed right there. So I remember in Python I use 42 a lot. I'm still here to find out why exactly we always have that 42. But that also guarantees that we have those sets coming out every time. So where's my output range? So my output range now will now be okay. Just put the starting point. So I click on this now. Okay, yeah, click here and then click on here. And then once all of that is done, I think we are good. Yeah, I think everything is done. So that's for uniform uniform distribution between 0 and 1. So I just click OK, And voila, we have the numbers. Okay. So we have the three random numbers. So of course, as usual, I like to what is that thing called now? To format, right? So I can just say rand one, okay, rand two, and then rand three. Rand three. Then I go back home, highlight all, then of course do some formatting. Yeah, centralize like I always like to do. Then come here and do all borders. Then come to the top and make all this bold. So you see, you have random numbers between 0 and 1 for so for three different variables. So that's for uniform distribution. All right. Of course, the idea of uniform distribution is that you have a range like 0 and 1, and you have 1 minus 0, maybe divided by 50 or something like that. And then you can get numbers within that interval. So this is uniform distribution. I can rename this also. And I say this is uniform. Okay. All right. Let's go back. Let's go to this place now. So I make it big for you to see better. Then I come again and I go again to data. I click on data analysis. Then now I'm still talking about random number distribution. I say, okay. So here, how many random number of variables do I want? Okay, let's just leave it at 3 and 50, not changing. I'll just be changing. Now I'm changing to normal distribution. So for normal distribution, right, the mean is 0 and the standard deviation is 1. So I can change the mean and standard deviation if I like. So I also want the output range to start from A1. The random seed is still 42. So I just change only the distribution now. So I have, okay, yeah, I just have okay. So again, we have random number distribution that is normally distributed now with with all this with the average what is it called? I mean 0 and standard deviation 1 or something like that. So again, I insert here, then I say rand 1, rand 2, and rand 3. Okay, rand 3. Then, of course, I highlight all, go home, centralize, centralize, rule everything, come to the top and make this bold. And now I have what? Random distribution. So this is now, sorry, I have uniform distribution, right? Uniform distribution like that. So that about uniform distribution. Sorry, it's normal distribution. Sorry, that's why it's giving that error. So I have normal distribution. Sorry, normal distribution, and there we have it. Okay, okay, it's time to. I can save this right now. I'm talking about random number distribution with the analysis toolpak. So I just come here, copy this out, okay, and use it as my file name. So I just paste it. That's number. I think that's the number 38 video, like that. Then I save it inside Microsoft Excel with EJD and I save. There I have it. So still on it, I want to check, I want to do all the possible distributions. Again, I come to the number third sheet. Okay. Okay, this time around, let me write the headers once and for all. Round 1, round 2. In that case, my range is going to start from A2, so no longer A1. So mind you, so I come again to data, then I come to data analysis, still talking about random number generation. Then I click OK. I still want three variables and then number of random variables 50. Then instead of normal distribution, I go for Bernoulli. So for Bernoulli, what p-value do I want? Okay, what p-value do I want for the Bernoulli? So of course, usually we want p-values less than maybe less than 0.05. Maybe I can go for 0.01. All right. So the seed is still the same. Now the output range is different. It's no longer A1. I could just change that A1 to that 1 to 2. But now I just want to, okay. I just click on this. That's where I want it to start from. So now it's Bernoulli with p-value 0.01. You could change the p-value also. And then I just click OK. So with that now, we have the Bernoulli distribution this way. Okay. No, Bernoulli distribution is either 1 or 2, like that. Okay. So that's Bernoulli right now. Okay. And then I just change this to, I just rename this to Bernoulli distribution. So then I can do all the formatting as usual. This, come up and do What's that? Okay, I think I opened a new sheet. Yeah, that's not what I want. Yeah, now we have this. All right, so I move to sheet 4 now. Again, I have rand 1, rand 2. That's random number 1, random number 2, and I have random number 3. All right, then I can expand. Okay, click outside and we can expand for more legibility. Okay, so now we move to the next distribution. I come for data analysis, random number generation. I say, okay, now everything is in order. Okay, well, let's change first to say, now we are going for binomial and p-value. We want p-value of, say, okay, I still go for 0.01. And then, you know, so I think binomial is 2 trials or something like that, if you remember the probability. So you can check my probability playlist to get clarity on Bernoulli, binomial, and things like that. So number of trials, let's say we want 5 trials, and then I think every other thing is fine. Now it's starting from A2, which is fine here. So we just click OK. And then Bernoulli and binomial are about the same, you know. Except for the fact that I think binomial is 1 trial or something like that. I don't have that clarity right now, but you can check my probability playlist to get that understanding. All right. So this is binomial now. This is now binomial. Binomial. We're good. So we're still on. All right. We go for the fifth one, I think. Then again, go to data. Let's do this again. So rand 1, rand 2, rand 3, rand 1, rand 2, rand 3. Okay. So we're starting from A2. Then I go here again, not random number generation. I say, okay, now I'm choosing Poisson distribution. I think that's for like rare events. So for lambda, can I say, let me just take 3 for lambda. Let's see how that goes. And then we just have okay right here. And then we have all these values uh for Poisson distribution. All right. So again, I do all the formatting back home, centralize, rule all through, then bold this and rename this as Poisson distribution. Poisson distribution. So we have all that. Then we go again. I think we have 1 or 2 more distributions. So data analysis, random number generation, okay. And then we have which other distribution? We have patterned distribution. So what are the parameters now? Well, I don't know. Parameters, let's say from 1 to 10, from 1 to 10 in steps of 0.1. I don't know if that is allowed, but if it is not allowed, fine. Repeat each number. I don't know. Repeat each number. I'll just take some random values. I don't know if there are some specific things I should do here. Repeating the sequence 2 times. I just do that. So it's pattern number, right? And the range is still A2, range is A2, and then I just click OK. So we have that pattern thing. So you can see how that comes, you know. That's how pattern number goes. So that based on all the things we specified, that's what we have. Okay, now it's even more than the 50 I was talking about. Let me look at the last thing. So it goes up to 547. Okay. So now we have rand 1, rand 2, and rand 3. Okay. So we can format home. Then we have this. Then we have this. Then up here, we bolden this, and this is patterned distribution. Patterned. So you follow all the specifications for the pattern, and then we have that. Then the last one I want to believe, again, rand 1, rand 1, rand 2, and rand 3. Okay. So we have all of this. Now, again, we go for data. We go for data analysis. Then we go for random number generation, already highlighted. Then we just say, okay. And then finally, we are going for discrete distribution. So We have value and probability input range. I don't know. Value and probability input range. Mm, I guess I'm not too sure about what this should be like. Value and probability input range. I don't know. Okay, well, let's stop here because I'm not too sure. Let me, I don't, okay, well, maybe let me use uniform distribution and see what happens. So I'll just come and do this. Okay, let me just use this. Maybe that helps for something. Okay, so I put that input range and then I just say, okay. So random number generation, input range must be a contiguous reference. Okay, so that's not working. That's what that means. So if I don't get this, I'll just forget about that. Okay, contiguous. Okay, yeah. Okay, it means I think it's about this now. Yeah, I'll just start from this A2. Let's assume that's what it requires. And I click OK. Discrete value and probability range cannot overlap with output range. Now I see what the trouble is. Okay, I mean, I'm sure I don't know what this is about, but we've had enough already. Like we have different kinds of distribution, so we could as well just stop it there. I'm not sure about what that should be. Okay, so we have these other ones. So with this, okay, let's see what are some use cases for random number generation, right? So this once configured, right? Okay, I mean, this tool is invaluable for statistical experiments, for things like Monte Carlo simulations, randomized control trials, and stochastic modeling. It saves time and ensures statistical rigor without the need for complex coding or scripting. However, it is important to know that once random numbers are generated, they are static, not dynamically updating unless the process is repeated, making it suitable for fixed data simulations rather than continuous updates. So with this, I come to the end of this video. Let me know how helpful this is for you. And if there's something you'd like me to try, feel free to let me know. If you have not subscribed already, you'll be missing a lot. So go ahead and subscribe, hit the notification bell so you can always get alerted each time a new video is released. You can also become a member of the channel. Click on join, and you find 3 levels of membership you can join, and then with the associated perks, special privileges that is. And don't forget to like, share, comment so that more people can have access to the video, to the content I have going on here. Till I come your way again, keep doing data right. Bye.